This question is from the Mechanical Engineering paper of GATE 2012. It's question number 48. Two steel truss bars AC and BC, each having cross-sectional area of 100 mm square, are subjected to a horizontal force F as shown in the figure. All the joints are hinged. If F is 1 kN, the magnitude of vertical reaction force developed at the point B in kilonewton is dash. So we need to find out the vertical reaction force at support B in kilonewton. So this is that vertical reaction force. In order to find this vertical reaction force, we'll need all the forces at this particular joint. So this is the horizontal reaction, let that be H, let this be V, H at B and V at B. We'll also need the force in member BC. Let's first assume it to be away from the joint. Now, we should start with the known value. So, the known value here is this horizontal force F. So, we'll start from joint C. First, we'll apply the equilibrium equations at joint C, find out the force in member BC, and then come to joint B. Again, apply the equilibrium equations to find out the vertical reaction at B. Let's see how this is done. So, at C, we have three forces, force F, force in the member AC, we can write it as FAC, and force in member BC. We can write this as FBC. The angles being 45 degree for this one and 60 degree for this one. Applying the equilibrium equations at this joint, first taking summation Fx equal to 0, we have minus of FAC into cos 45, which is towards the left. So we have minus FAC cos 45 plus F, and horizontal component of FBC is minus of FBC cos 60 degree, which is equal to 0. So we have a relationship here. Taking both these terms on the other side, we have FAC into cos 45, that is FAC upon root 2. Cos 45 is 1 by root 2 plus FBC upon 2. Cos 60 is 1 by 2. This will be equal to F. Let this be equation 1. Now taking the other equilibrium equation, summation Fy equal to 0. We have all the forces in vertical direction are positive FAC times sine 45 minus, this will be negative because this is downward as per the assumption. So we have minus FBC sine 60, which is equal to 0. Substituting values here, we have FAC by root 2 minus FBC into root 3 by 2, because sine 60 is root 3 by 2 is equal to 0. Let's find out FAC in terms of FBC and then substitute it in this equation to get FBC. So we have here FAC simply will be FBC into root 3 by 2 into root 2. So we have root 2 into root 3 by 2 times FBC. This turns out to be FAC is equal to under root 6 by 2, which is nothing but all over root of 6 by 4, that is all over root of 3 by 2 times FBC. Substituting this in the equation 1, we have under root 3 by 2 into FBC. This is the value of FAC divided by again root 2 plus FBC by 2 is equal to F. We have to be careful while substituting the value here. There are high chances of making mistakes. Taking all the coefficients correctly, we substitute the value. Now FBC can be taken common and found out. So FBC taken common is equal to F. Coefficient of FBC on this side will be root 3 by 2 plus 1 by 2, or coefficient of FBC on this side was 1 plus root 3 by 2. The common denominator in both the terms is 2. So we have this as into 2 by 1 plus root 3. This comes out to be 0.732 times F. F is given in kilonewton as 1 kilonewton. So we have value of FBC is 0.732 kilonewton. Now that we have the force in member BC, we can go ahead to find out vertical reaction. At joint B, taking the free body diagram of joint B, we have three forces here. The vertical reaction VB, horizontal reaction HB, and the force in the member BC, which has turned out to be positive 0.732. So the direction that we assumed was correct. It is tensile force of 0.732 kilonewton. Now to find out the vertical reaction at B, we can simply take equilibrium equation summation Fy equal to 0. No need to take the horizontal equilibrium equation, because in the vertical equilibrium equation, the only unknown coming will be Vb. So we can write this as Vb is upward, it is positive. This force is also upward. So we have plus 0.732, but its vertical component. So this angle was 60 degree. This will also be 60, being the alternate angle. So we have vertical component of 0.732 is nothing but sine 60 degree into sine 60 degree equal to 0. So VB is negative of 0.6339, which can be rounded off 0.634 kilonewton. We have the vertical reaction at B. Let's go back and mark the correct option. We don't have to mention the sign, only the numerical values. Numerical value is 0.63 kilonewton is the vertical reaction developed at point B. To learn more about trusses and the analysis of forces in trusses, you can refer to the NPTEL video Lecture 8 Trusses 2 from the course Engineering Mechanics. This course is by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.